How do we solve this algebra problem? K times K minus K times K equal to 100. K times K times K could be written as K to the power of 3 minus K times K could be written as K to the power of 2 equal to 100. K to the power of 3 minus K to the power of 2 is equal to 100 could be written as 125 minus 25. Let's continue. This implies that k to the power of 3 minus k to the power of 2 is equal to, we can rewrite 125 as 5 to the power of 3 minus, we can also rewrite 25 as 5 to the power of 2. Now, let us transfer each of these guys to the left hand side correspondingly. So that will be k to the power of 3 minus 5 to the power of 3 minus k to the power of 2 plus 5 to the power of 2 equal to 0. Let's continue. It is possible I can put these guys in brackets. So I have k to the power of 3 minus 5 to the power of 3 in brackets. To put these two guys in brackets, we need to factor out the negative sign. So that will be minus into k to the power of 2 minus 5 to the power of 2 equal to 0. At this stage, we need to recall some beautiful properties. The first identity is a to the power of 3 minus b to the power of 3 is equal to a minus b times a square plus ab plus b square. The second identity is difference of two square. A square minus b square is equal to a minus b times a plus b. Take note of these two identities, very important. Applying this first identity to this guy, we have k minus 5 times k square plus 5k plus 25 minus, also applying this second identity to this guy, we simply have k minus 5 times k plus 5 equal to 0. You will see that k minus 5 is common. We can factor it out. So we have k minus 5 into this k square plus 5k plus 25 minus this k plus 5, close the brackets, equal to 0. K minus 5 times, let us drop these brackets, we have k square plus 5k plus 25 minus times k minus k minus times 5 minus 5 equal to 0. K minus 5 times k square 5k minus k, that is 4k, 25 minus 5, that is plus 20, equal to 0. This implies that k minus 5 is equal to 0, or k square plus 4k plus 20 is equal to 0. Clearly, from this line, k is equal to 5. This is the first solution. K equals to 5. Now, if you look at this quadratic equation very well, it is not factorizable. So let us solve it using quadratic formula. K equal to minus b plus or minus the square root of b square minus 4ac divided by 2a. From this equation, a is 1, b is 4, c is 20. Plugging these values here, we have k equal to minus, what is b? The value of b is 4. 4 plus or minus square root of b square. If you plug 4 here, we have 4 square minus 4 into a is 1 and c is 20. Everything divided by 2 into a is equals to 1. Let's continue. K equal to minus 4 plus or minus square root of, what is 4 square? 4 times 4, 16, minus 4 times 1 times 20, that is 80, divided by 2 times 1, 2. K equal to minus 4 plus or minus square root of 16 minus 80 minus 64 divided by 2. K equal to minus 4 plus or minus. I can rewrite square root of minus 64 as square root of 64 times square root of minus 1 divided by 2. K equal to minus 4 plus or minus. What is square root of 64? That is 8. And square root of minus 1 from the complex number is what? Is I. So we have I here divided by 2. K equal to, it is possible I can factor out 2 from this numerator. If I do that, I have 2 into minus 2 plus or minus 4i divided by 2. K equal to, clearly 2 cancels 2. We are left with minus 2 plus or minus 4i. This implies that K is either equal to minus 2 plus 4i or K equal to minus 2 minus 4i. Therefore, all the solutions that we have for this algebra problem are, the first one is K equal to 5. Let's call it K1. And we also have K equal to minus 2 plus 4i. Let us call it K2. And last but not the least, K3 equal to this guy, minus 2 minus 4i. So in total, we have 3 distinct solutions for this algebra problem. That's it. Thank you so much guys for watching.